All right, boys and girls, welcome back to the drive-thru. Special shout-out to mangoes. Hard to cut, delicious to eat. Okay, so hopefully you're starting to recognize that we are matching cones with pyramids, and we are matching cylinders with prisms. Because I want you to imagine a prism that's made up of 100 gons. What is that thing going to look like? It's going to look just like a pop can. And I want you to imagine a cone that's base is 100 gon. It's going to look just like a cone. Sorry, I shouldn't have called it a cone. I meant a pyramid whose base is 100 gon. Do you understand that? It's very important. If you can do that, then once again, I know you will figure out these lateral area formulas. Okay? So these are regular pyramids. If they're not regular pyramids, then the way you find lateral area is just add up all the sides, the area of the sides. So, a couple things here. One, this is the height of the pyramid, okay? And this is the slant height of the pyramid. Which of those two things do we use to find volume? We use the regular height. Which do we use to find lateral area and surface area? We use the slant height, okay? So what you should imagine is that if we cut and unpeeled the sides of that pyramid, you would get what's called a map that looked just like that. Could you imagine that? Okay? And like I said before, this is a regular pyramid, so all of those bases are the same. Okay? So the lateral area is the area of the sides. That's the area of the triangles. They all have what for the height? They all have the slant height for the height, because those triangles have been folded. So if you think about it, the lateral area is the area of the triangles, so it's 3 times 1/2 times, excuse me, I should have drawn my bases on here, base times slant height, okay? Well, what is 3 times the base equal to? That's equal to the perimeter of the base. Do you get that? So that's where they come up with the lateral area of a pyramid is 1/2 perimeter times slant height. If you don't like that, then you can just use this one. It works fine. You don't need to memorize that as long as you know the area of a triangle. But here's where it does pay off. So, similarly, we have an R, an H, and an L for a cone. Notice, we could not unfold a cone and get this type of shape. In fact, I don't know if you know it or not, but you would get this type of shape. Okay? However, if you can think about a cone like a pyramid with an infinite amount of sides, then you should very easily be able to come up with the lateral area for a cone. What does this stand for right here? 1/2 the perimeter of the base times the slant height. Do circles have perimeter? They do not. What do they have? Circumference. So it's 1/2. What's the circumference of a circle? I'm going to call it 2 pi r, and you'll see that for a reason, because the 1/2 and the 2 are going to cancel. And then times what? No. Times the slant height. That's the answer. That's the lateral area of a cone. Although, what does the 1/2 do with the 2? They cancel because they multiply to be 1. So pi RL is the lateral area of a cone. If you memorize that, you are very likely to forget it by next week, and you're going to do poorly on cumulative assessments. If you understand what we just did, that a cone is simply a trippy, wild version of a pyramid, then all you got to know is that a pyramid is made up of triangles. We're going to add up all the triangles, or we're just going to multiply 1/2 times the perimeter times the slant height, and that's the same thing we're doing for the lateral area of a cone. Okay? Thinkers unite. Boom!